Hi, NodeConf. Welcome to the Healthy and Fit Wombats for the Greater Good. I'm Szabolcs. I'm from Budapest, Hungary. I work at IBM as a senior developer. When I'm not working at the office, I'm doing blogging, organizing meetups, and running conferences like JSConf Budapest and CSSConf Budapest. We are a proud member of the JSConf family. Come visit us in next September. But now let's get down to business. We have a problem. Probably everyone has seen this image, the heaviest object known, the node modules folder, ripping the space-time continuum apart. Our first reaction is like, oh yeah, it's hilarious, we know. No, it's actually not. But then, this is kind of a compromise. We have a system of lots of small modules building on each other. This is kind of like, it's how it is. But seriously, what's going on here? First, the ecosystem is open, easy to use for everyone. Putting and getting modules from and to NPM is easy, and it should be. There's no problem with that. Keeping limitations low and being welcoming is really, really important, and partly this is why NPM is so widely used and great. But as time goes and we become more mature and wise and, let's face it, old, and publish more and more packages, we should just stop sometimes and ask this question, what's really in these packages what we are working with? So back at my workplace, we started to roll out internal NPM packages, first at a Sinopia instance, then we switched over on-premise hosted NPM enterprise, and we started to be mindful what we actually put in the packages because like they use space. And then I went out to the public registry because I was curious what is going on in the real world, what is actually people doing. And that's the reason why I'm here, because I've started a small investigation. And trying to get a view on the packages, I have managed to install roughly 1.5% of the whole registry onto this machine. This resulted in more than 12,000 packages into a single project. You don't want to do this at home. It takes a lot. Time and space. So the node modules folder is nearly 5 gigabytes. But then I felt I may have some representative numbers on the situation I have. So I started to scan this node modules folder and looking for files, folders, patterns, what result or emerge, anything that appears most of the packages and stand out for some particular reason. First, the easier one, files that turned up. Anything that is not related explicitly to the working code, the functionality of the package, remains of build processes, CI builds, configurations. 14% of packages will install their Travis config. Might be useful. Also, there are a number of hint files, lint files, editor configs, make files. After finding all these common files, I started to look for more exotic content like images, animated GIFs, videos, larger binaries, and I was shocked. All the following images that are coming after this slide are actual images inside NPM packages right now on the registry. I wouldn't blame any maintainer from this stage, so I will only show the image sizes and the weekly download numbers. Beware, some shocking numbers are coming. If the node modules further rips the space-time continuum, no wonder there's a galaxy inside it. 300 kilobytes, almost 4,000 downloads a week, 40,000 downloads a week, sorry. The next picture, oh my God, it's full of starfishes. It's a nice piscatorial scene with 300 kilobytes and over 200,000 downloads a week. Huge swan, half megabytes. No wonder there's a grumpy cat too in NPM. This cozy little internet shack is downloaded more than 140,000 times a week, and this map surrounding Zurich, twice as many, both in size and download numbers. And finally, my two favorites, the Mary Fellowship, hiking in the mountains. I think it's the Tatra Mountains, really popular, more than 110,000 downloads per week. And Captain Picard complaining about GIF loading times. According to the download number, he's doing it 38 times every minute per week. These are in NPM packages, or at least some of them were. I started to send pull requests to the maintainers, update their npm-ignore file or package.json files, and some of them are already merged. Thank you, folks. The ecosystem loves you. On to the folders. Stuff that remained there from Git repositories, like tests, examples, documentation. Now, 12 and 14%, that might not sound a lot, I get it. But let's take a look at the size they actually use. Taking all that is not related to functionality, summarize it, and average it on the package count on this computer. And that resulted in 16 kilobyte average on every package overhead, 60 kilobyte data not related to the functionality of the package. Looking at the size, that's 5.8% of the whole Node modules folder. Still, it might not sound a lot, but let's see other aspects of this number. According to the NPM statistics publicly on their page, there are more than 29 billion downloads a month. Let's multiply it with 16 kilobytes, and we got a number. It's 473 terabytes, totally useless traffic over NPM every month. To put it in perspective, all the media on Wikimedia Commons, which is a freely usable media files, are only 190 terabytes. NPM is burning money on tests and Travis configurations. I'm pretty sure that kind of money could be spent elsewhere, make it a better use. And before we move on, let's just think about that for a moment, okay? Now, it's not a new issue, but as the package count grows and grows, it's becoming more and more visible. TJ Holloway-Chuk even wrote a tool in Go to clean out the trash from the Node modules folder based on a handful predefined list of files and folders. It's not specific to packages released by newcomers to the ecosystem. I've seen these in packages by maintainers who are really with us since the beginning of Node. I won't mention package names or starting to point fingers in this room. It's not the characteristic of NPM itself either. It's not the way it is. NPM stores what you publish. This is the job of NPM. It's not their fault we put our trash in there. It's ours. We did this. We're doing this right now. So let's try to fix this. Let me show you some ways how. First, the most important thing, and probably the most obvious thing, keep your dependencies separated from development and from production. There are other kind of dependencies too, like peer dependency, which you can use to tell your users what your package is compatible with. Thinking about some broader, higher level thing like React or Babel core. It won't install the package inside it since NPM free, but it will show you a warning if it's missing from the whole install running install process. And there's the optional dependency, which is basically really optional. It won't do any error if there's missing. You have to handle the missing package in your application. Actually, it's just a list of packages that might be optional for your package. That's it. And there's the bundled dependency. I'm not putting it on the slide because that what you list in bundle dependencies will literally install modules into your tarball when you create the NPM package, so please use that only when needed. If you do an NPM install package name on your computer, it saves default to the production dependencies. So be very careful with this, because install modes like production or development are cascading through your dependency tree. And so if you do a development install, all your dependencies will do a development install. And if you do a production install, all your dependencies will do a production install. So it takes a single package in your dependencies with a misspelled dependency somewhere or module, and you end up with a complete build pipeline or in production. So use save dev or save optional or use no save at all. In automated environments, when during build or production, you can trigger a production-only install using the production flag, or even better, set the node environment, node env environmental variable to production. Many applications use this variable, so it's useful to do it anyway. Second, what we can do, we have to differentiate how we approach packages. We can install them and use them, So we are consuming NPM packages, and we can write and publish them, so we are contributing to the ecosystem. This is two different behavior, requires two different things. If we are consuming, we are interested in what's in the package, what that will do some work in our application. I'm talking about the code itself, some documentation in the form of man pages if we are looking at a CLI tool, and some lifecycle scripts that will run at different times during npm install or publish. I may have left out some things, but essentially these are the things we are doing npm installs, right? We should not include the dependencies in our production, so why keep the test there if we cannot run them? Huh? On the other hand, if we are contributing, we are really happy to see the tests, the documentation, the example in the Git repository. So these things should stay there. You can put pictures there, like Guy Fieri. If you ever want to do such thing, please put Guy in your Git repository. For reference, this was a satirical post by Jordan Scales on Medium, which was making a point of the black box nature of node modules and suggesting there's a picture in Babel core. I don't think this picture ever was in Babel core, but that's not the point. npm can help us to put things where they belong by using include and excluding lists and doing a nice report on npm publish. Maybe the simplest thing is just define what you want to include in your package. The package.json field has this field called files. It's an array of folders, file names, and matchers. You can put the list of your main content there that you wish to be packaged. This is parsed using minimist, the module minimist, so the same rules apply. You can create negate matches, so to exclude specific content from included folders. So it's possible to create really detailed configuration for your npm package. Certain files are always included, regardless of these settings, like the package.json itself, the README, changelog history, license, and the file that is referenced in the main field of your package.json. If you want to take another approach, you can exclude things from your package. You can rely on npm-ignore and gitignore, these two dot files. Whatever is in gitignore, that won't be packaged into your node module. If you have things you want to leave out from the package but keep in Git, you can create an npm-ignore file and list them as the same way you would do it as a gitignore. Inclusion is much powerful than exclusion. It's such a nice rule, easy to remember. In this context, it means whatever you define to be excluded from your package in the dot files, it gets included if you list them in the files section in your package.json. This way, you can gitignore your build that goes to the package, but it won't go to the Git repository. Since npm 6, there are nice statistics of your published package after running npm publish, where you can see a list of files, their size, what's going to be toggled, and the complete size of your package. It's a nice and quick overview to check your publish configuration. You don't have to really publish everything just to test. You can use the flag dry run to run a test publish. The third thing what we can do and try is to focus and specialize our packages. I'm talking about targets and plugins. When I'm talking about targeted packages, it may be part of some larger library or tool set, but sliced down and separated to target some specific area like platforms, frameworks, versions of frameworks. If you want your package to be prepared for everything, it might result in a bloated Swiss knife. I don't think that's a nice thing to look at. Instead, be smarter, like Enzyme, for example. Enzyme is a testing framework for React components. It has a separated adapter packages for each React version. So this way, you can configure your test runner to the React version you're actually using. And the Enzyme core and the adapter packages can remain small and more maintainable. The next approach is making plugins, where you can put specific capabilities, features, and add-ons into separated packages. I'm talking about small, specific tools that can be combined for the job you need to be done. I personally find this picture more pleasing than the huge Swiss knife before. For example, Babel, where you can pull in features as packages, extend the transpile capabilities of Babel, and use only what you need. Now, approaching your library like this might result in a large number of modules, I get it. If you're concerned with all these small packages are somehow getting untrackable, use the scopes feature on NPM, use it as a namespace, so you don't have to worry about someone else taking over your next feature you want to do over NPM. Still, there's the issue how to maintain and publish a small horde of modules and packages. Well, this is just an authoring workflow issue. As many things in a developer's life, it can be automated. Many large library maintainers use this tool called lerna to handle this very issue. This tool takes a single Git repository with many folders containing code logically separated as npm packages. In any time, you can take out the code in the package folders and use it as a separate own npm module, but it handles them together accordingly. With a single command, you can install dependencies to each of the little modules, and you can even cross-link them if they depend on each other. You can run all your tests or any npm command with a single command from the top level of your packages. It uses semantic versioning, so it will calculate your next version number according to your Git commit messages. And to publish all your packages to npm, it's just a single command, lerna publish, and that's it. It is used by React, Babel, Angular, Ember, keeping maintainers sane, I think. And the most basic tool for us may be npm itself. So before I go to the end, I would like to take a look at the fun parts of npm scripts. It's good to know what's happening during install and publish and where you can join this process to do some work. These are called lifecycle scripts, and there are a few for install and publish workflows. I feel it's important at least we know about these, and when there's a need, we can use them to solve simple problems that we might overcomplicate otherwise. If you do a local install, meaning a simple npm install command in a project folder, 3 scripts are ready to run, called pre, post-install, and prepare. If your package is installed as a dependency, only the pre and post-install will run. Small but useful advice. If you wish to access the main project from your dependency, the npm puts it in the init.cvd environmental variable, so you don't have to look for it, it's just right there. During publish, we have a few more steps available. Since npm 4, there is prepare, which runs both on install and publish, so it might be impractical at this time, but there's pre-publish only, which runs only at this time before the tarball is created, which is surrounded by pre-pack and post-pack. And then, in the end of the publish cycle, there's a post-publish script. Pre and post, these 2 small words sure appeared a lot. The best part of them, you can put them before any of your scripts, and it will run before or after the prefix script. Not just special scripts like start. You can create a start script in your package.json, and if you do a pre-start and a post-start script, it will be run automatically before and after start. But you can use it with any script command in the package.json file, like build, pre-build, and post-build. You can create your complete build flow simple and easy just by using npm scripts this way. It's such a great tool. Some takeaways, useful things to bring home. Please take care of your package. Check out what's in it before your next npm publish. Keep it focused, keep it simple, if possible. If you need a quick fix of your package, I made this npm-ignore-default package. If you install it as a development dependency, it will update or create a gitignore file during the install and put some useful defaults there. These are the defaults I used for my investigation, and the same defaults that were used in the module of TG Holloway-Chuk to clean out the trash from the node modules folder. If you're curious what's inside the node modules folder on your projects or on your machine, I put the code I used to do this investigation into a module called npm-analyze. If you install it as a global tool, you can run it on your project. And it will tell you if there's any content that should not be packaged according to your files field in the package.json and your ignore files. My plan is to make this tool work as a local dependency, so it will install a pre-publish only script and prevent publishing if there's unnecessary content. If you use the deps flag, you can look at any node modules folder, and it will show you some nice statistics of the state of your node modules folder, like how many dependencies are in the package.json, how many dependencies are actually installed, and what size they take up, what is the useless content in there, and what's the average on each module. This is basically the thing I use to do the investigation on this computer. Watch your content on npm, please. Don't forget to keep an eye on what you put there. Now, this talk covered just the raw content of npm packages. If you're concerned with more details like security, compatibility, and licenses, be sure to remain here in the room and then after the break and check out the talk of Beth. She will be awesome. Thank you for listening. I hope you found this talk useful. If you want to chat about my adventures in a huge node modules folder, or IBM, or JSConf Budapest, for which I have some stickers, find me later today or tomorrow. Let's keep the ecosystem happy and the wombats run happily ever after. Thank you very much.